Hello everyone. This video is going to be about how to create buffers from point data in FME Desktop. For this tutorial, we'll be using a shapefile which contains doctor locations in the city of Toronto. By the end of this video, you should have a good understanding on how to apply this with your own dataset to help you with your data challenges. In this video, we'll be covering what buffering is, transformers you're going to want to use in FME Desktop, understanding our transformer parameters, and how to aggregate buffers to a single polygon. So what do we mean when we say creating buffers around a point? Now, if you're not familiar with geospatial data, you may be scratching your head and probably thinking I'm talking about something like this. But what we're actually referring to is creating area polygons around point data for specific distances. Now, what is the use case for creating buffers around our points? Well, it's usually for proximity-based analysis. For example, buffering zones around locations are often used to set up protection zones around the environment, or to protect residents and commercial zones from industrial accidents or natural disasters. So let's jump to our FME workbench. So the data we're going to be working with is a shapefile which contains doctor locations in the city of Toronto. If we inspect the attributes, you will see that we have a doctor ID, latitude, longitude, and admin district column. The data's coordinate system is LLWGS84. So the end result I'm aiming for is to create one polygon with a 1 kilometer buffer around all my locations to see what doctor coverage looks like in this area. In order to create our points around our polygons, we're going to be bringing in the buffer transformer into our FME workbench. So we're going to want to make sure that the buffer type is set to 2D. The buffer distance refers to how big we want to make the buffer. I want to make 1 kilometer buffers around my points, so I'm going to change the buffer distance units to be kilometer. If I leave it to ground units, none, then it's going to create a buffer in decimal degrees, since my data is currently in a geographic coordinate system. I'm going to set the end cap style and corner style to round. When I set the parameters to round, it allows me to control how smooth the buffer is going to be around the locations. The smaller the interpolation angle, the more vertexes are added to our output polygon, which can actually add a lot more processing time depending on how many points we are working with. I'm going to use 1 degree as my interpolation angle, as this is a fairly good balance. I'll come back to the dissolve on attribute, but let's first run the workbench to see what our initial results will be. So when we ran the workbench in enable feature caching mode, what we notice is that each point location now has a 1 kilometer buffer around it. Since I want to create a polygon that combines all these buffered locations together, I'm going to need to join the data. We can achieve this if we have a common attribute in our dataset that we can use to combine it on. In this case, I have an admin district column which I'll be using since all the locations share the same district name. So when we now run the transformer again, what you'll notice is we no longer have 888 features back, but rather only 3 because all the polygons that overlapped were now combined together. If you don't have a common attribute, then we can actually use the dissolver transformer to get the same result as using the dissolve on attribute parameter in the buffer transformer. I'm going to create a dissolve count attribute called doctor count to give us the total count of doctor locations that we have aggregated in each polygon. I'm also going to drop incoming attributes to clean up my output attributes. So after this finishes running, you will see that this gives us the same result as the buffer transformer, but with the added benefit of adding the total count of the dissolved doctor locations and removing some unwanted attributes. If you want a full dissolver transformer guide, then check out my last video here. So the next step will be to combine 3 polygons together to get 1 polygon instead of 3. To achieve this, we will need to bring in another transformer called the aggregator. If I accept the defaults of this transformer, it will aggregate all the area polygons that come through the input port. The only parameter we will want to change is the drop incoming attributes and set attributes to sum to be the doctor count column. This will allow us to keep the total amount of doctor locations that went into our polygons originally. So when this finishes running, we will now have 1 polygon which contains a 1 kilometer buffer around all my doctor locations, with the total doctor locations in the polygon in the doctor count attribute. We can now use this polygon as an input for further analysis in FME, or simply write it to a format that supports geospatial data such as Shapefile to save the results. So I hope this tutorial was helpful and you now know how to buffer points in FME Desktop. Please leave a comment below if you have any questions. Thanks for sticking it out to the end, and please like and subscribe so you don't miss out on my next tutorial. See you next time.